name is Xiong Chen, and I'm studying the NTU. And today I want to talk about a hybrid robotic system for harvesting heavy produce. At the beginning, I want to ask everybody one question. Do you like to eat fruit? Raise your hand. Thank you. Actually, I very like to eat the watermelon and the melon. It's very sweet. So I will think about that. How do people to harvest this type of fruit? Because it's very heavy. So I look for the paper and find it. In the traditional way, there will be a lot of people to harvest this heavy fruit. But today, the people want to harvest this one by the machine or robot. So I will talk about a little information of robot. There are three kinds of typical robotic systems. And the first is serial robotic system, and the second is parallel robotic system, and the final one is hybrid robotic system. The serial robotic system is that. The picture is the robot of KUKA. And the serial robotic system is like your arms. And it can have a large workspace and flexible motion, but it has some problem with it. Less stiffness, small payload, and high inertia. And the parallel robotic system is like this. This is the Stewart platform, and one kind of parallel robotic system. And the parallel robotic system has high structural stiffness and a great payload and accuracy, but it sacrifices the workspace of that. In this paper, he wants to combine these two kinds of robotic system. We call that hybrid robotic system. This kind of system can have the advantage of the serial robotic system and the parallel robotic system. So they want to use this hybrid robotic system to harvest the heavy fruit. And this is the serial part and the parallel part. This is the working process for harvesting produce. At the beginning, the end effector of the robot will be attached to the target and stretch the arm to the target and get it down. This is the picture of that. This is the construction of the actuator control system. And at the beginning, they just use the P controller to control the actuator. So this is the behavior of only use the P controller. We can see they use the 4 kind of payload to the system. And the 7.5 kilogram and the 5.5 kilogram cannot get to the desired position. So they want to solve this problem. They use the fuzzy controller, and after they using the fuzzy controller, they eliminate the steady state error of the system when the payload is 7.5 kilogram and 5.5 kilogram. The conclusion: the hybrid robot was effective and capable of handling heavy agricultural products, such as metals, and could be controlled precisely enough for use in harvesting. And in this experiment, the position control result of the development hybrid robot showed that it could be controlled within A is positive or negative 1 micrometer and millimeter and positive or negative 0.2 degree range of error. Thank you.
Presentation. Thank you for your presentation. And I have a question about, you have shown that your robot can catch the food about 7.5 kilograms.
Yes.
Today, if one day the food is heavier than that, what will happen?
It is really didn't mention about it, but I guess there will some problem of this system. Yes, but maybe they can do a lot more experiment of the more heavier pedal. Yeah.
More questions?
In your hybrid system, and how to move the machine by the because I only see you can move the arm to reach the target, and can you move the backside part of the original paralyzed system to reach the target, or still use the arm part? Thank you.
And in this paper, they just talking about to with the high pedal and the robots perform, how was the robot performance when it get a high pedal. But I think if in the future they want to apply this system to the real life, maybe they will add like a car, small car under the bed and into the farms to harvest the fruit, I guess.
Very good question. So, more questions, please.
It might be a very difficult question. I want to ask about how the parallel robot works, how it works.
In this photo, as example, you can see there will 6 arms of this system, right? And every arm is the linear actuator, so they can stretch or decrease its length or increase its length. And they use these 6 arms, the left change, the length of the 6 arms, the change. They change the length of 6 arms. They can make this plane on the top to move. Yeah. So it's
Okay, thank you.
Is that the advantage of the robotic system? Can you explain more about the third one, the high inertia? What is it?
Inertia, just like when I make a turn, and I don't open my arm. I just turn like this. It's very easy, right? But today I open my arm, and if I have the heavy one on the end of my hand, and I want to make turn is more difficult than if I don't have any book like it. And this system is just like the power up. And if they have some pedal at the end effector, and they do the motion, they will just like the situation I just speak. So the inertia, just like it will easy to cause the much moment in dynamics. I don't know how to.
More power consuming or?
Yes.
Have some some difference, because for this kind of robot, I mean, it's one on the other top. So the less one, the big one, has to support all the other, the weight of the other link. Yeah. So I think the most important is because it is serial magnetic, not like a parallel robot. Can you go to the next slide? This one, the weight is supported by 6 things. They don't, for example, this link is not support all the other links, the weight of the other links. And it makes the energy more efficient. Thanks for your presentation. I have a question. Does the finger of the robotic system have the material to protect from the fruit get hurt during the harvesting?
They don't mention about this because this hybrid system just in the experiment stage, so they haven't finished this part.
Okay, thanks.
How the arm can how is the arm can cut off the stem? But because I think just like a watermelon or a melon, its stem is very yes. So I think this motion cannot cut the fruit off.
They don't mention about it, but I guess I guess they will change the tool of any effector or have the 2 kinds of any effector on this, so they can do the cut, and after they get the fruit. Yes, I guess. But they just discuss this system, the behavior of this system when it need to get a heavy fruit. Yes.
Thank you.
Okay. So because of time, so problem. Any questions from Japan?
Okay. Are there any questions here?
I think hybrid robot system need much space as well parallel robot system. Can it solve workplace problem? Thank you.
Excuse me, can you repeat your problem again?
Hybrid robot system. I think hybrid robot system need much space as well parallel robot system. Need large
You said,
workplace.
if you say the hybrid robot system needs more space than parallel
As well
robot system.
as as well parallel robot system. So can it solve workplace problem, workplace disadvantage?
Let me rephrase that. Okay. The robot, and the hybrid robot now, takes up a lot of space on the ground. But if you go into the real world, in a real field, there is not so much space. You are planting. How can you solve the problem of having a small space that the robot can use in the field?
I think it is impossible because at this experiment they want to take the heavy fruit, and the heavy fruit we need to let our base more stable. So the parallel part of this system, I think they will not be very small. But because I have searched the like watermelon, the bunch of watermelon, they have a lot of space. We can put this robot in the farm to harvest. So I think that is not a problem. Is that? Yeah, answer your question.
Thank you. My name is Ueda. I developed the watermelon harvesting robot 20 years ago. We use more simple parallel linkages. And I'm afraid your robotic construction is too complex to use in agricultural operations. And my colleague, Dr. Satoru Sakai, submitted IEEE transactions. You can see our research results. I would like for you to read Satoru Sakai's transactions. And construction is more and more simple.
Thank you. Are there any more questions?
Thank you for your presentation. I have a question. Each part of the fruits that the machine sees when the machine picks up the fruits, and it's a stroke point, a stroke part, or the cue part, which one the machine sees. Thank you.
So can you repeat again your question? Sorry.
Which part of the fruits the machine will seize? The cue point or stem point, stroke point.
It's the first one you just do.
Stroke point. Yes.
Not.
Because I think the fruit size is very different, so the machine will pick the stroke point is the better, I think.
Let me rephrase that. When you are picking up a melon, does the robot identify the middle part of the melon to pick up, or what part? How does it identify which part to try and pick up?
In this paper, the picture they show the picture I see in the paper, they catch this fruit on its body.
Okay, so they use a round melon or round shape, or do they use a long, elongated style of melon?
Yes.
Which one? Which one? Is it round or is it a long, elongated style?
Oh, they just idea the fruit like a ball.
A ball,
And,
okay.
okay. So yeah,
Okay.
they don't mention about the short one or another one.
Okay, thank you very much. That's all the questions from Kyoto.